All right, so let's take a look at 7.5 arithmetic series. Okay, so the only difference between a series and a sequence, as you can see here, a sequence would look like this: 1, 3, 5, 7, 9. They're all separated by commas, meaning this is term number 1, term number 2, and so forth, and you can figure out any term number you wish. Obviously, the first term in this sequence is 1. The common difference in this sequence is 2, because you're going up by increments of 2. And so you can come up with a TN formula for this, any term formula for an arithmetic sequence. Now, if you're talking about series, the series is the sum of all the terms. So instead of being separated by a comma, it's separated by a plus sign, or it could be a negative sign. But basically, series are the sum. This would be the sum of the first 5 terms. So in order to get the sum of the first 5 terms, you would have to add term 1 plus term 2 plus term 3 plus term 4 plus term 5, which is very, very different than term 5. Okay? Term 5 would just be 9, the 5th term, and that's it. The sum of the first 5 terms would be adding the first 5 terms together. So the formula for an arithmetic series is this formula right here. Everything means the exact same except S, instead of TN, so instead of term number whatever, it is the sum of the first however many terms they're asking for. And N still means the same thing, the number that, however many numbers you're adding together, okay, or term number. A is the first term, and D is the common difference. So example 1 says, find the sum of the first 60 terms of each series. So this one here, as you can see, it's exactly like a sequence, except it's asking for the sum of the first 60 terms. So you're looking for the sum of the first 60 terms, not term 60. So this operates the same way as a sequence. The first number is 5, second number is 8, third number is 11. The next number, if you look at this, there's a common difference of 3. So you're always adding 3 to get to the next number. So the next number has to be 14, and so forth. Okay? It wants the sum of the first 60 terms. So again, my A value is 5, because that's the first term. There is a common difference, and the common difference is 3. The common difference is 3 because you're going up by increments of 3 to get to the next number. And my N would be 60 because I'm trying to find the sum of the first 60 terms. So as soon as they're talking about sum, I'm going to write that formula down. So Sn is equal to n over 2, 2a plus n minus 1 times d. And then I'm just going to plug these numbers into the equation. So sum of the first 60 terms would be 60 over 2, and then this is going to be 2 times a, which is 5, plus my n is 60 minus 1, and then times d, which is 3. So sum of the first 60 terms is going to be 60 divided by 2, which is 30. And then you're going to go 2 times 5, which is 10, plus this is going to be 59 times 3. So sum of the first 60 is going to be 30, and then I will have here 10 plus 59 times 3, same as 60 times 3, 180 minus 3, it's 177. And so sum of the first 60 terms is going to be 30 times 187. And continuing this, sum of the first 60 terms is going to be 30. And I'll just take out my calculator for this one because I'm on the spot here. So 30 times 187, it's 5,610. So if I took the sum of the first 60 terms, meaning I would write the first 60 terms and add them all together, I'd get 5,610, which is a lot different than term 60. Term 60 is not equal to this, okay? It's the sum of the first 60 terms is equal to this. The next problem I'll set up for you, but I will not do it. So this one here, -6, minus 8, then minus 10, then minus whatever. Now, you could imagine that this is the same as having a plus sign, you know, so -6 plus -8 plus -10, but they don't have to write the plus there. If you look at this, the a value here is -6. That's the first term. The common difference, though, is -2, because in order to get to the next number, you're subtracting 2. -6 minus 2 is -8, and then -2 again is -10, and then -2 again, this would be -12. And then my n is 60 because it's asking me the sum of the first 60 terms. So I would use the exact same formula, except I would use a, d, and n as these 3 numbers. Okay, so I'll let you do that one on your own. And then if I look at example 2, it says, find the sum of the arithmetic series 5 plus 9 plus 13 plus all these numbers in the middle, and then the last number is 201. So this one's actually pretty tricky. It gives you the first 3 numbers, then it says plus ... means there's a whole bunch of numbers in between here, and then plus, this is the last term. Now, it says that this is the last term because there's no plus sign afterwards, so it stops here. It says find the sum of this arithmetic series. This arithmetic series goes from here all the way to 201. So essentially, if you had all the numbers in there, add them all together, what does that equal? So let's take a look at what everything is. My a value, I know for a fact is 5 because that is the first term. Now there is a common difference here because the common difference would be adding 4s. Okay, to get to the next number, you're just adding 4s. So the next term would be 17, then 21, and so forth, all the way up until you got to 201. So the common difference is 4. The only thing we don't know is actually how many terms are there. We don't know that. So it'd be impossible to actually find the sum of that entire series. Now, in order to find the sum of the entire series, remember the sum of an arithmetic series is calculated by using this formula. So after using this formula so many times, I'm not going to have to memorize it because it will be ingrained in me. So finding the sum of the first how many terms? We don't know. We know what a is and we know what d is, but we just don't know how many terms there are in this series. So what we're going to do is we're going to find out how many terms there are first. Once we know how many terms there are, then we can solve this problem. See, right now I know that this is term number 1, and I know that this is term 2, and I know this is term 3, and so forth. What's this term? I don't know. This is term n, the last number. Okay? If I knew what term this was, let's say I knew this was term 50, then I know there are only 50 terms. Or if I knew this was term, I don't know, 40, I know there are only 40 terms. If I knew this is term 32, I know there are only 32 terms. I can go and solve that. But I don't know how many terms there are. So I'm going to first have to figure out what term number this is. How many terms are there? Now, what do we do in order to solve anything regarding term number and an arithmetic sequence or series? Well, if you're talking about term number and arithmetic, you're talking about this formula here. Tn is equal to a plus n minus 1 times d. That's how you find the term number for any arithmetic sequence. Now, I do know that, again, my a value is 5. My d value is 4. But I do not know what my term number is, okay? So I'm going to plug this in here. I'm going to get term n is equal to a, which is 5, plus n, I don't know, minus 1 times d, which is 4. But if I continue this here, I'm going to continue this by saying the term number I'm looking for, right, instead of writing Tn, I'm going to write 201. because that's the term number that I'm looking for, right? This term number is equal to 201. So I'm going to plug in term number equals 201, and I'm going to be able to find out what n is equal to, what term number that is. So I plugged in Tn is equal to 201, and I will find what term number that is using this term number formula for arithmetic. Expanding this all out, I'll get 201 is equal to 5 plus, this is 4 times both things in there, so I'll be 4n minus 4. So I get 201 is equal to 4n, and 5 minus 4 is positive 1. Bring the positive 1 to the other side, it'll be 201 minus 1 is equal to 4n. Or 200 is equal to 4n. Divide out the 4 from both sides, and I'm going to get that n is equal to 50. Okay, because 200 divided by 4. So n is 50. So this tells me that there are exactly 50 terms in this series. So Tn, this is actually term number 50. That 201 is actually term number 50. Now that I know this, I can figure out the sum of the first 50 terms, because there are only 50 terms in that formula, in that series. So if I plug this in, I get sum of the first 50 terms is equal to 50 over 2. 2 times a is 5 plus n, which is 50, minus 1 times d, which is 4. Continuing this, I'll get sum of the first 50 terms is equal to 25 times, and then this is going to be 10 plus, and this is 49 times 4. So sum of the first 50 terms is going to be equal to 25. 10 plus, and then 49 times 4 is 196. And so then when I do that, I'm going to get sum of the first 50 terms is equal to 25, and that plus that is 206. And then I'm going to do sum of the first 50 terms is equal to, and I'm going to do 25 times 206, which is equal to 5,150. So the sum of the first 50 terms of that is equal to 5,150. Now obviously you'll have word problems associated with these types of sequences and series in your homework. For instance, they may ask you a question regarding a theater, and a theater could have 5 seats in the first row, 9 seats in the second row, 13 seats in the third row, and in the last row it has 201 seats. And then it may ask you how many seats are there in total in the entire theater. That would be a problem that would be associated with this series. So again, a theater has 5 seats in the first row, 9 seats in the second row, 13 seats in the third row, and in the last row it has 201 seats. How many seats are there in the entire theater? That would be this exact question, except with words, okay? So you got to be careful when it's asking you for how many seats are there in total, or it may ask you how many seats are there in the 50th row or in the 51st row. That would be finding the term number, okay? If they just want how many seats there are in just one of the rows, that would be the term number. But if they want, the sum of all the seats, then that would be a series. Okay, so it would be the sum of the first however many aisles there were in the theater, in rows in the theater.